Welcome back to my class in statistics. For today, we will take up presentation of data in frequency table without using class intervals or classes. Such presentation of data in a frequency table without using class intervals or classes is referred to as ungrouped data. For our example, consider the following data. These are scores of students in a 25-item quiz. The data given are 20, 18, 15, 25, and so on. And we will present this data in a table, frequency table. A frequency table is a tabular presentation of data. A tabular way of summarizing and presenting data, such as this scores of students in a 25-item quiz. In the first column, we write X. X denotes the score. And in the first column or column X, we will arrange the scores in ascending or descending order. I will arrange the scores in ascending order. That is, we start from the lowest. And the lowest here by inspection of the given scores is 15. Followed by 17. And there is 18. There is no 19. After 18, we have 20, 21. And there is no 22, no 23. The highest score is the perfect score of 25. Now we tally each score in the second column for each score that appears in the given data. In the given set of scores, we make one tally, 20. We make one tally for 20, and we encircle 20 to make sure that, to indicate that 20 has already been tallied. Next we have 18, one tally, 15, one tally, 25, 21, one tally. So these scores have been tallied. We have 18, 17, 21, 21 is already tallied, 18, 17, 18. These three scores have been tallied. In the second row, we start with 25, 17, 21, 25, 20. 17, 21, 18, 17, 21, 18. And the last three scores are 15, 20, 21. 15, 20, 21. Now, the next column denoted by F is the frequency column. F stands for frequency. And frequency indicates the number of times that a given score appears in the set of data or in the distribution of scores. 15 has a frequency of 2 corresponding to tally of 2. Discount the tally for the frequency. 17 has frequency of 4. 18 has frequency of 5. 20 has frequency of 3. 21 has frequency of 5. And 25 has frequency of 3. We add the frequency column for summation of F. And we have 2 plus 4 is 6, plus 5, 11, plus 3, 14, 19, plus 3 is 22. And the sum of frequencies is our sample size, denoted by N. Now for this set of data, which is small, we can check if we really have 22 scores. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So our tally is correct because we obtained the correct total number of scores of 22. The second column is the RF column with percentage in percentage, and RF stands for relative frequency. Now the relative frequency expresses each frequency as a percentage of the sample size. Again, frequency F indicates the number of times that a score appears in the distribution of scores. For instance, this frequency of 5 means that the score 18 appears or occurs 5 times in this set of data. Example, the last 3, this frequency of 3 means that 25, the score of 25 appears 3 times in the set of data. Or equivalently, 3 students have perfect score of 25 in the class. Relative frequency will express each of these frequencies as percentage of the sample size. Hence, the formula for computing relative frequency is given by RF equals frequency divided by sample size times 100%. The relative frequency denoted by RF is computed by this formula. We divide each frequency by the sample size, and the quotient is multiplied by 100%. And we will do that for each of these frequencies. We divide 2 by 22 and multiply by 100%. And if you get an answer of decimal number, you round off your answer to 2 decimal places, and a calculator would be very useful for calculating relative frequencies. Compute the relative frequency of 15 has a frequency of 2, and divide 2 by 22 and multiply by 100%. We have 2 divided by 22 multiply by 100, and you should get 9.0909. The third digit from the decimal point is to be rounded off if we want our answer to 2 decimal places. And the third digit from the decimal point based from the answer in the calculator is 0. And it is less than 5, so we simply drop 0 and all the digits to the right of 0. And to 2 decimal places, the answer should be 9.09. And this is in percent. The relative frequency of 15 is 9.09. The relative frequency of 9.09% means that 9.09% of the sample of 22 students, or 2 students have scores of 15. Now we compute the relative frequency of 17 with frequency of 4. We divide 4 by the sample size of 22 and multiply by 100%. We have 4 divided by 22 multiply by 100%. And you should get 18.1818. The decimal, the digits 18 is repeated without end. 18.1818. Again, we round off the third digit from the decimal point. From the decimal point, the third digit is 1. And since it is less than 5, we drop 1 and all the digits to the right of 1. Hence, the answer to two decimal places is 18.18. 18.18%. The relative frequency of 18.18% means that 18.18% of the sample of 22 students have the scores of 17. And 18.18% of 22 should give you 4. There are 4 students who with scores of 17. Now we find the relative frequency of 18 by dividing its frequency 5 by the sample size of 22 and multiply by 100%. We have 5 divided by 22 multiply by 100. And you should get 22.72. The digit 72 is repeated without end. And we round this up. If we want to round this up to two decimal places, the third digit from the decimal point should be rounded off. And that digit, third digit from the decimal point is 7. And 7 is more than 5. Hence, we add 1 to the preceding digit, the digit preceding 7, which is 2. We add 1 to 2. And the answer to two decimal places is 22.73. 22.73%. 22.73% of the sample of 22 students have scores of 18. And 22.73% of the sample of 22 students rounded off the whole number is 5. There are 5 students with score of 18 and they represent 22.73% of the sample of 22 students. The relative frequency for 20 is obtained by dividing its frequency 3 by the sample size 22 and multiply by 100%. We have 3 divided by 22 multiplied by 100. And we should get 13.636363. The digits 63 is repeated without end. And we round this up to two decimal places. The third digit to be rounded off is the third digit from the decimal point is 6. And 6 is more than 5, so we add 1 to the preceding digit, 3. And the answer to two decimal places is 13.64. 13.64%. This means that 13.64% of the sample of 22 students have scores of 20. And 13.64% of the sample size of 22 rounded up the whole number is 3. And these 3 students with the same score of 20 represent 13.64% of the sample size of 22 students. The frequency of 21 the relative frequency of 21 with frequency of 5 is the same as the relative frequency of 18 with the same frequency of 5, 22.73. And the relative frequency of 25 with frequency of 3 is the same as the relative frequency of 20 with the same frequency of 3, 13.64%. 13.64%. Now we check if we obtain the correct relative frequencies, and we do the checking by adding the entries in this column, in the relative frequency column. The sum when rounded up to whole number should be exactly equal to 100, not more than 100 or less than 100. Again, the sum of the relative frequencies when rounded up to whole number should be 100%, not less than or more than 100%. So we add the entries in the relative frequency column. We have 9.09 plus 18.18 plus 22.73 plus 13.64 plus 22.73 plus 13.64, and the sum is 100.01. Our summation of the relative frequencies is 100.01%. But I said that the sum of the relative frequencies when rounded up to whole number should be 100%. If you round up 100.01 to whole number, the answer is 100%. If you get a sum, if you round off your summation of relative frequencies to whole number and you get like 101 or 99%, then one or more of your relative frequencies are incorrect. The next column is CF. CF stands for cumulative frequency. The cumulative frequency is known as the running sum of the frequencies. For the first score, the cumulative frequency corresponds to the frequency of the first score. The frequency of 15 is 2. Its cumulative frequency is also 2. And that is only true. We only do that for the first score 15. Again, for the first value x, the cumulative frequency corresponds to the frequency of the first value of x, or the first score. For the other scores, we continuously add the frequencies of the scores. We have 2 plus 4 is 6. And 6 plus 5 is 11. 11 plus 3 is 14. 14 plus 5 is 19. And 19 plus 3 is 22. You would know if you have obtained the correct cumulative frequencies. The last cumulative frequency should always be equal to the sample size n. Now, how do we interpret the cumulative frequencies? The cumulative frequency of 6 means that there are 6 students with scores of 17 or below. Again, the cumulative frequency of 6 means that there are 6 students with scores of 17 or below. In particular, 2 of the 6 have scores of 15 and 4 of the 6 students have scores of 17. Now, the cumulative frequency of 14 means that there are 14 students with scores of 20 or below, 20 or less than 20. Again, the cumulative frequency of 14 means that there are 14 students with scores of 20 or below 20. Specifically, there are 2 of the 14 students with scores of 15. There are 4 of the 14 students with scores of 17. And 5 of the 14 students have scores of 18. And 3 of the 14 students have scores of 20. And 14 is equal to the sum of these frequencies, 2 plus 4 plus 5 plus 3. 14. Now, if you are asked this question, how many students have scores of 18 or below 18? Just look at the cumulative frequency of 18 and your answer should be 11. There are 11 students with scores of 18 or below. If you are asked the question, how many students in the class have scores of 21 or below? And your answer is the cumulative frequency of 21, 19. There are 19 students out of 22 students in the class with scores of 21 or below. That's how we interpret the cumulative frequencies. Since we have discussed arithmetic mean or the mean that is computed from a frequency table, we compute the mean for this sample of 22 scores. As I mentioned in the previous lesson, if you have a frequency table like this, the mean denoted by x bar is computed by the following formula. Again, if you have a frequency table like this and you want to compute the mean, the formula you will use is this formula. X bar stands for mean, and it's equal to the summation of the products of the score and the corresponding frequency. And the summation of the products fx is divided by the sample size n. And to compute the mean from this table, you first compute the product fx, where x is the score and f is the frequency of the score x. And we do that in this column denoted by fx. We multiply the score by its frequency. For 15x, we multiply 15 by its frequency 2. Or 2 multiplied by 15 is 30. For 17, we multiply 17 by 4. Or fx is 4 multiplied by 17 and we get 68. For the next score, 18, there are 5 students with scores of 18 and we multiply 5 by 18 and we get 90. Next, for the score of 20, the frequency is 3. We multiply frequency by the score and we get 60. Next, we have score of 21 with 5 students having the same score of 21. We multiply the frequency 5 by the score 21. 5 multiplied by 21 is 105. And lastly, we have 25 score, and there are 3 students with score of 25. We multiply 3 by 25 and we get 75. After you get the products fx you now get the sum or summation of these products. And to get the summation from the table, we add the entries in the fx column. And we denote the sum as summation of fx. And we add the entries in this column. We have 30 plus 68 plus 90 plus 60 plus 105 and plus 75. Let's do that again. 30 plus 68 plus 90 plus 60 plus 105 plus 75. And you should get 428. And the summation of the product fx is divided by n, or the sample size. We now write x bar summation of fx is 428. And divide by the sample size. The sample size n is 22. We have x bar equals 428, we divide by 22. And you should get 19.454545. The digits 45 are repeated in that order without end. And we always give the final answer to 2 decimal places. If you want the answer to 2 decimal places, the third digit from the decimal point should be rounded off. And the third digit from the decimal point is 4. Since 4 is less than 5, we simply drop 4 and all the digits to its right. And we do not add 1 to the digit preceding 4, which is 5. Hence, the mean to 2 decimal places is 19.45. I will do this last column. This is the angle in degree, because I would like to present this data, summarize this data in graphical form. But we will do that next time together with the cumulative frequency curve, or known as ogive or ogive, the vertical bar graph, and the horizontal bar graph. We will present this data graphically in vertical bar graph, horizontal bar graph, the cumulative frequency curve or ogive or ogive, and the pie chart or pie graph. That's why we have this column for angle in degrees. For your practice, please try the following exercise. For the given data below, summarize the data in frequency table and compute the mean. Also, interpret the RF, that's relative frequency, and CF, that's cumulative frequency of 7. And these are the data given. We may take this as the scores of students in a 15-item short quiz. In the first column, we have 3, 7, 11, 9. Second column, 5, 6, 5, 15. Third column, we have 6, 8, 7, 8. Fourth column, 2, 3, 8, 7. In the last column, we have 4, 954. And this is what you will do. You will summarize the given data in frequency table. In the first column, you write X, second column, tally, third column, the frequency column, fourth column, the relative frequency column, and the next column is the cumulative frequency column or CF. Since you are asked to compute the mean, you need this summation of Fx column. In actual research paper or undergraduate thesis, we only present in the table the score, the frequency, and the relative frequency. We do not show anymore the tally column in the research paper, as well as the cumulative frequency, as well as the Fx column, because we have a software to compute the mean. Now, if you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe or ask your friends to subscribe to my YouTube channel, Art Calison. Thank you for joining me in my class today.